Okay, welcome back. We will perform procedure number 3. Okay, for procedure number 3, we are to measure the weight of the beakers. So, a while ago, I have presented to you 3 beakers. Beaker number 1, beaker number 2, and beaker number 3. Okay. I have to wipe this dry to ensure that I will be weighing only the mass of the beaker and not the water therein. So, I'm trying to wipe it dry. Okay. So, at this point, I will be using the platform balance. Okay. So, beaker number 1, okay, number 2, and 3. Okay, how do we weigh using this platform balance? So, I'll put the mark into 0. See to it that it hangs into proper place. Okay. I have to put off the fan beside me so that it won't interfere with the weighing scale, because as air blowing through this can move these pans in both ways, so it will interfere with our proper observation. Okay. Now, it was previously calibrated, so we can say that it is properly calibrated if after putting in the marks, the scale marks to 0, our pointer here, our pointer gauge, should point directly into the middle calibration. So if you could notice, that is in place, so we can say that our platform balance is well calibrated. If this deflects a little bit more on this side or on that side, you need to adjust, and we use this knobs here to adjust. Okay, going here this way would tilt it on this side, moving this way it will tilt that on this side. So since it is properly calibrated now, I can start weighing. So to weigh, we place the material to be weighed on this side. Okay. Okay. 10 grams, not enough. Okay, let's put the counterweight, 60, that's more than enough. 30. Okay, a little bit. Okay, so we'll see. So 30, 40 is over the scale. 30, a little tip on this side, so meaning it's not enough. So we need to add. Okay. And move this until we get this marker here on this middle portion. Ayan. Slowly. Okay. There we go. Okay. So our reading now is 33.9. 33.9. That's beaker number 1. 33.9. Record your observation. Okay. Now, let's use another beaker. Beaker number 2. Okay. It's a little bit tipping into that side, so we need to adjust. Okay. Okay, a little bit more. 33. Okay, 33.8. 33.8. Okay. Let's remove this and fill and put in the third beaker. Okay, 33.7. So, the first beaker is 33.9, the second beaker is 33.8, and the third beaker is 33.7. Okay, so those are the measurements we had for the weight of these beakers. Okay. A while ago, we measured the volume of the pea ball. Now, I'll wipe this pea ball dry. Okay. Kanina, we have the volume of the pea ball. Now, we will determine the mass of the pea ball. Okay. So, 30 is more than the mass of it. So, I'll move it to 20. Okay. 20 is not enough to counter the weight of this pea ball, but 30 is more than, so I'll stick with the 20, then I'll move this. Okay, going towards 20 plus 10, that's more than the weight, so I'll continue adjusting it. Okay, there we go. Until it points into the middle. Okay. There we go. Okay. So it reads 20 plus 2.8. 20 plus 2.8. Yes. 20 plus 2.8. How much is the weight of our pea ball? Or the mass of our pea ball? 20 plus 2.8. Note the observation. Okay. Now, for this part of the experiment, all you need, once you have the volume and the weight of the pea ball, you're going to measure the density. And the density is expressed in gram per ml. By the way, 1 ml is equivalent to 1 cc. Try to note that. Anyway, you have that conversion on the beginning or on some theoretical background for that experiment. It is there on the handout actually. Okay, so to get the density, so density is defined as the mass per unit volume of an object. So mass divided by its volume, you will get the density. So how much is the density of the pea ball? Take the mass, as we have determined, and divide that by its volume, as we have determined earlier. Okay. That's all for this part of the experiment, and we will proceed with the next part.